welcome back to the workshop. Today we join a team of resourceful craftsmen turning a mountain of raw plastic waste into functional furniture. Unsorted polymers require high, sustained heat to break down their rigid chemical bonds. Continuous agitation prevents the heavier synthetics from scorching at the bottom of the basin. Once the material reaches a workable viscosity, it is extracted to cool. A heavy steel cylinder serves as a makeshift industrial roller. Pressing the semi-molten mass eliminates trapped air pockets that would otherwise compromise structural integrity. The resulting slab reveals a dense, marbled composite of fused synthetics. After the slab cures into a rigid sheet, it must be shattered back into manageable pieces. This coarse reduction is necessary before the material can enter any mechanized processing. A rotary crusher handles the secondary breakdown. Heavy steel blades chew the jagged fragments into smaller, uniform particles. Dust generation is inevitable when fracturing brittle polymers at high speeds, making respiratory protection a strict necessity. The spinning flywheel maintains rotational momentum, allowing the motor to power through the densest chunks without stalling. What began as a volatile mixture of discarded waste is now a standardized raw material. Bagging the granulated plastic keeps it dry and prevents cross-contamination from the surrounding workshop floor. Moisture is the enemy of the final molding phase. Sealing the sacks completes the initial preparation stage. The stabilized material is ready for the factory line. Inside the facility, the crushed granules are fed into an industrial extruder. Gravity pulls the plastic down into a heated, rotating screw mechanism. Extreme thermal friction melts the granules back down, homogenizing the various types into a single liquid. The thick steam is a byproduct of residual moisture evaporating off the polymer chains. This steady, viscous flow indicates a properly calibrated internal temperature. The molten strands are immediately drawn through an ambient water bed. Rapid cooling shocks the plastic, solidifying its outer layer so it can withstand mechanical tension. A set of precision rollers then feeds the hardened strands into a rotary cutter. This mechanism converts the raw streams into standardized, uniform pellets. These small, dense pellets are the universal currency of industrial molding. Their uniform size ensures they will melt at exactly the same rate in the final machine. The finalized pellets are measured and loaded into the hopper of an injection molding machine. Precision is critical here. An exact volume of material guarantees the mold cavity fills completely without overflowing. Any leftover stock is carefully sealed to prevent dust ingress. A clean supply line dictates the strength of the finished cast. Storing bulk material directly on the concrete floor helps regulate its temperature before molding. The yellow injection unit operates at immense pressure, forcing the melted pellets into a rigid metal cavity. The mold separates to reveal the payoff. Immense clamping force and rapid cooling have transformed the reclaimed pellets into a seamless structural piece. The craftsman inspects the base for any weak points or incomplete flow lines. Surface flash is minimal, proving the machine's tolerances are tightly dialed in. What began as a chaotic pile of discarded waste is now a precise, load-bearing object. Industrial reclamation is not just about melting scrap. It is the deliberate reordering of matter. Out of the refuse, utility returns.